Adult development. Image 150. Infancy, trust vs mistrust. Early childhood, autonomy vs shame and doubt. Early school, initiative vs guilt. School age, industry vs interiority. Adolescence, identity vs role confusion. Young adulthood, intimacy vs isolation. Maturity, generality vs stagnation. Old age, integrity vs despair. Neurogenesis, neurons being born. First neurons during 2rd embryonic week, EU. At 7th EU you produce 500,000 neurons/minute. 18th EU completed, the brain excessively overproduces neurons and the connections among the neurons, and through use, it gets rid of the neurons and connections. 2-year-old has 55% more gray matter density in the frontal lobe than an adult. 20% more at 5. 10% more at 7. Neurogenesis continues into adulthood in the olfactory bulb, and in the dentate gyrus of the hippocampus. Gould saw new neuron in the prefrontal cortex of monkeys, but Rakic said it was really glia. Glia support the neurons, and you make glia thought out your whole life. So, neurons are not generated in adult cortex, except in your dentate gyrus and olfactory bulb. Exercise will pump up the number of neurons you make in the dentate gyrus of the hippocampus. Hippocampus equals memory. More blood volume due to exercise equals more new neurons equals better memory. Cell migration, across radial glia tracts following molecular cues, and they reach their destination which is programmed in these cells. Synapses, part between neurons where information flows. These are the connections that the brain overbuilds, which the brain gets rid of synapses that aren't useful throughout your life. Myelination, growth of the fatty sheath that's around the neurons that are extending distances, it insulates them and accelerates their signal, white matter. From age 4 to 22, you get rid of gray matter, and enhance white matter. You're getting rid of the neurons and the synapses that are non-productive, gray matter, and you're increasing the strength with which different parts of the brain can communicate with one another, white matter. The prefrontal cortex is the last to do this. Amygdala equals fear. Rats learn attachment through olfaction. If you pair them though conditioning, odor, shock, odor, shock, odor predict the shock. Until day 9 they still approach the odor. But on the 10th day, they avoid the odors that predict the shock. Then, they look at the metabolic activity in the amygdala. For the 9 days old it doesn't activate. And at 10 day old, they have a big response in the amygdala. Which suggests that if you're a very helpless newborn, you have to go things no matter what because you need the help of other to survive, but at some point, you realize about the bad things, to avoid them. And even in families where there's tremendous abuse for a young child, the abused child remains powerful, loyal to their parents. Is this a mechanism that mixes up attachment and fear and you can't separate them so well? We don't know. 1800s, life expectancy of mid-30s. 2010, 78 years. Maybe 50% of girls born in 2000 will live for a century. Cross-sectional studies, you only measure 20 years old. Longitudinal studies, you study people from their 20s, until their 60s. Image 28:00. Cognition and aging. Working memory, speed of progressing, long-term memory, it starts declining since you're 20 years old. World knowledge, like knowledge of vocabulary, goes up since the 20s. With aging you lose speeded capacities, you gain specific knowledge or experience. Air traffic controllers. Age influences processing speed, but not task performance. If they're testies in a flight simulator, they do it badly, but after the first trial they can apply their prior experience, and get better at it in the following trials. Young equals raw processing, speed, and flexibility. Old equals knowledge and expertise. Long-term memory performance goes down fast year by year as you get older. Image 34:00. Memory tasks. Young adults, activate one side of the prefrontal cortex, whether it was verbal or spatial. Older adults, activates both sides of the brain. Because older people who used both frontal cortices were actually doing better. They compensate for the decrease in long-term ability by applying more neural systems to support your performance. How to avoid the damage of aging. Education. Lifelong cognitive activity. High conscientiousness. Exercise. If you do all you have less chances to get AD. Also, once you get the diagnosis of AD, then the more educated you are, the faster you decline. Because more education equals cognitive reserve, mental tools, you have more abilities to use, that will protect you from brain injuries. But once AD becomes severe enough, and those tools are no longer available to you, the more educated you are, the more you plummet, because everything's gone. AD starts in your brain about 15 years before you get the diagnosis. You want to catch out people at 55 to 60. Exercise experiment. People over 60s assigned to 2 groups to exercise. 1 walking, swimming. 2 toning/stretching. Hour/day, 4 months. Group 1 had much better cognitive performances. Group 2 had almost no benefits. Also benefits in the white and gray matter of the brain. Socio-emotional selectivity theory. Young adulthood, you acquisition of information through adventure. Old age, you regulate your emotions. Younger people focus more on the negative options relative to older people. But it's because of age or time. It's not whether you're 20 or 60 or 80. It's how long you sense time is in front of you, a temporal horizon. If you show a positive image to an old person, they will get more aroused. If you ask them 2 weeks later about that picture, they will remember more a positive image than a negative one. Positive image to a young adult, they won't really care. 2 weeks later, they will remember more a negative image than a positive. Amygdala equals emotions formulate the formation of new memory. The amygdala of older people gets much more activation if they remember a positive thing, than a negative. For young people, the amygdala activates about the same whether is positive or negative. Reward system. Involves the neurotransmitter dopamine. Starts in the ventral tegmental area, part of the brainstem, nucleus accumbens, inferior porting of the basal ganglia, called dopaminergic reward system. Anticipation-reward, release dopamine. Also, once you do the same process again, even when you know you're about to get the reward, you release tons of dopamine. But if you don't get the reward, your dopamine goes down the pipe. What's delicious for the brain is the anticipation of something that's rewarding, rather than the reward itself. Then, ventral tegmental area nucleus accumbens medial prefrontal cortex, inferior parts of your frontal lobe. The medial prefrontal cortex gets activated when you get the reward. Nucleus accumbens equals anticipation. Medial prefrontal cortex equals reward. Old people are less responsive to potential loss, but equally responsive to potential gain as young adults. Adolescents. Their nucleus accumbens gets activates like crazy, but their medial prefrontal cortex barely activates. Which means the reward system areas are developing way faster than the cortical areas, which control and regulate behavior. 40% adult alcoholics started drinking around 15 to 19. Between 16 to 20 are twice as likely to be in accidents than drivers between 20 to 50. Adolescent is more likely to engage in impulsive sexual behavior and multiple partners. Annually 3 million adolescents contract a sexual transmitted disease. The younger you are, the faster you waste money. Creating false memories. The example when people tell you to write down a list of things. All things on the list are related to sweet, like chocolate, honey, soda, etc. And a lot of people say they hear the word sweet, but in reality, the people didn't say this word. Because your mind thinks about the essence of things, not the details of things. Then, they did this experiment to 80s vs 20s-year-old. As a result, older adults have many more false memories, and they perform less well. Older equals more false memories. Because they encode the gist, but lose the specifics. Children equals less false memories than 20 years old. As you get older, you understand what's important, it's not the little details, it's the big concepts. The older you get, the more you realize and more is about social affiliation. Framing heuristic. People are risk-averse for gains, but they're risk-taking for losses. Lives saved 72%, lives lost 22%. These choices are not present in preschooler or second graders. They don't show the symmetry for losses and gains. The preschoolers are more logical than older people. Because there's no reason to be statistically different for losses and gains, it's purely an attitudinal emotional perspective. E.g. swim with sharks. Adults, gist, bad idea. Adolescent, weight the factors, will be safe in a group, how shallow is the water, etc. Unprotected sex. Adults, you get infectious disease. Adolescent, what's the odds, purely statistically, a single sexual experience you will have the pleasure of sex, but you will end up with a terrible disease. Adolescents are more accurate in their assessment of risk, not wise in their choice. Adolescents are curiously thinking about what are the factors, it's not the best analysis, but it's almost more rational. Adults make more just errors memory, more emotional in their avoidance of risk.